Welcome to the Sleep to Dream Analytics Explainer video, where better sleep starts with better understanding.
Welcome to The Explainer. Tonight, we are pulling back the curtain on one of the most mysterious and universal parts of our lives, sleep. We're going to learn how to decode the silent, complex language our brain speaks every single night. I mean, have you ever really thought about it? Sleep isn't just your brain flipping an off switch. It's not a nightly shutdown for repairs. Not at all. It's actually an incredibly active, precisely choreographed performance where some of the most critical work for our mind and body gets done. You can think of a full night's sleep kind of like a play in 5 acts. There's a script, there are different scenes, and there's a rhythm that carries us all the way from dusk till dawn. So today, our goal is to read that script, to really understand the journey, which is all made possible by the science of sleep scoring. But, before we can read the script, we need to understand the language it's written in. So let's take a quick look at the toolkit scientists use to map out our nightly journey. It's a process called polysomnography, and it's basically just the way to listen in on the conversation happening between your brain, your eyes, and your muscles.
It all really boils down to these 3 main measurements. The EEG, that listens to the electrical chatter of the brain, telling us what state it's in. Then the EOG, that watches for any telltale eye movements, even when your eyelids are shut. And finally, the EMG checks the tension in our muscles. You put those 3 signals together, and you get the complete record of the night's performance.
All right, the stage is set. Our journey starts the second our head hits the pillow. Act 1 is about to begin.
So, our starting point isn't actually sleep at all, but a very specific kind of wakefulness, stage W. You're lying there, eyes closed, and your brain is producing this really distinctive rhythmic signal called the alpha rhythm. Think of it like an orchestra tuning up before the show begins, a state of calm, relaxed readiness. Okay, so as we start to drift off, that steady alpha rhythm just fades away. We are now entering stage N1, the shallows of sleep. This is that really light, transitional state, where you're not quite awake, but you're not really asleep either. It's a very brief, fleeting stage, kind of like the gentle curtain raiser for the night.
Now we're getting somewhere. Stage N2 is what a lot of people consider the start of true sleep, and it's where we spend about half our entire night. It's defined by the sudden appearance of 2 pretty fascinating and very distinct brainwave events that scientists believe are absolutely crucial for keeping us asleep and helping us learn.
So first up is something called the K complex, and it is exactly what it sounds like. It's a big, complex, really dramatic spike in the brainwave reading. It's this huge, isolated wave that just stands out so clearly from all the background chatter, kind of like a single loud clap in a quiet room. The thinking is that K-complexes are a protective mechanism, helping to block out sounds and other things from the outside world to keep us from waking up.
And the second key marker is the sleep spindle. These are short, intense little bursts of rhythmic brainwaves that are generated deep inside the brain. They get their name from their unique shape, which kind of looks like a spindle of Fred. And these things are fascinating because they're heavily linked to memory consolidation. Taking short-term memories and locking them into long-term storage. The more spindles you have, the better your memory might be the next day.
So, from the lighter sleep of stage N2, our brain takes another dive, descending even further into the deepest and most restorative part of the whole night. This is stage N3, or as it's often called, slow-wave sleep. It's totally dominated by these huge, powerful, synchronized brainwaves called delta waves. They're very slow and very big, like these long, rolling ocean waves. And this is your brain in its deepest state of rest. It's when your body does its most critical physical repair work, like releasing growth hormone and strengthening your immune system.
Now, after hitting the absolute depths of N3 sleep, our journey takes a completely surprising turn. We actually come up from that deep quiet into the most famous, most mysterious, and honestly, most paradoxical stage of them all.
For the longest time, researchers had no idea this stage even existed. Then, back in 1953, a scientist named Eugene Aserinsky happened to notice his son's eyes darting back and forth under his eyelids while he was asleep. He called them jerky eye movements, and that one little observation completely revolutionized everything we thought we knew about sleep.
So, here's the crucial point. Sleep isn't just one thing. It is split into 2 fundamentally different states. You've got non-REM sleep, those are the stages we just covered, where the brain gets progressively quieter and quieter. And then you have this other state, REM sleep, where the brain becomes incredibly active, but the body becomes completely still. Stage R, or REM sleep, is just defined by this bizarre combination of features. You've got the rapid eye movements, an EEG that looks almost identical to being awake, and, critically, a near-total loss of muscle tone. This is the body's safety switch, a kind of temporary paralysis called atonia that keeps us from acting out our crazy, vivid dreams. This is the prime time for emotional processing and creative problem-solving.
So we've seen all the individual acts in our play. Now let's zoom out and see how all these pieces fit together across an entire night to tell a complete story.
See, we don't just go through these stages once. We cycle through them over and over again. Each full journey from light sleep down to deep sleep and then up into REM takes about 90 minutes. But the character of these cycles changes as the night goes on. The first half of the night is really heavy on that deep, restorative N3 sleep for physical repair. But the second half of the night, that's dominated by longer and more intense periods of REM sleep for all that mental and emotional housekeeping.
And this is what it all breaks down to for a typical, healthy night. We spend a whopping half of our time in that gateway stage N2 sleep. A full quarter of our night is spent in the wild, paradoxical world of dreaming and REM sleep. And the rest is split between that super deep N3 sleep and the little bit of time we spend drifting off in stage N1.
So we've learned to decode the signals. We can read the moment-by-moment script of a night's sleep with incredible precision. But this just raises the biggest question of all, doesn't it? Now that we can actually read the story, what is it trying to tell us? What are the great mysteries still hidden in the dark? Well, that's what scientists are still working to unravel, one dream at a time.
Thank you for watching the Sleep to Dream Analytics Explainer video. We hope you sleep well and dream easy.